Okay, good morning, everyone. As I discussed with you earlier, and as I mentioned in our group, today we are going to start unit number three. The questions of Bernoulli's equations will be discussed on next Friday today because actually we have done an extra class on Friday. As it is an extra class, definitely I should give you the recording. Actually, there should be enough time to cover that lesson. That's why I shift that lesson into Friday. Correct? Okay, so today we are going to start unit number three. Unit number three means waves and oscillations. Waves and oscillations. So this is unit number three also a very important lesson in physics today because this is the most easiest question, easiest unit among our 11 units today. Actually, unit animation is also easy, but the thing is, actually there are only one or two questions. But in waves and oscillations, we will have a lot of questions. But this unit is very, very easy unit. This is the easiest unit in your syllabus. Okay, so if I discuss about the preparation, you will have approximately 9 MCQs. 9 MCQs in this unit. Okay, so actually, waves and oscillations. Unit number 3. Unit number 3. Waves and oscillations. Actually, we can categorize this unit into three major categories. First one is oscillations. Then waves. Then light. Those are the three major categories in this unit today. Oscillations, waves, and light. So altogether, we will have 9 MCQs in this unit today. Then definitely there will be a structured essay question. Definitely there will be a structured essay question. Structured essay, one question. It may be light or waves. It may be light or waves. So structured essay, one question. Then essay. Essay, there will be a one question. There will be one question. So that is the content of our paper. No, this is a normal content of our paper. So MCQ, 9 MCQ means actually we will have 9 mark in our final paper. Structured essay means 5 marks. No, 5 marks in the final paper. Essay means 7.5 marks in the final paper. So altogether 14, 21. 21.5. That means approximately 21 marks can be taken from this unit. And most important thing is this is very, very easy unit. Therefore, you can get them 21 marks. What do you have a question? Essay question. Essay question. ඒත් එහෙම ලොකු අමාරුවක් නෑ. හරිද? ගොඩක් වෙලාවට ඔය මේ වෙනවා paragraph questions තියෙන paragraph questions එනවා. හරිද? සාමාන්‍ය අපිට ඉස්සරන ගොඩක් කරලා පේපර් එක structured essay එක අපිට આવුත් එහෙම light වලින් essay එක එනවා waves වලින්. essay එක waves වලින් આવොත් structured essay එක light වලින් එනවා. ඕක අවුරුද්දෙන් අවුරුද්ද මාරු විදිහ තමයි. සමහරවල් දැන් නම් වෙනස් වෙන්න තියෙනවා. එක ළඟ views ආවා. ඊළඟට දැන් ගිය පාර ලයිට් ආවේ ගොඩ කාලයකට පස්සේ මේ පාර එන එකත් එක්ක ඔයගොල්ලන්ගේ පාර එන question එක depend වෙනවා. හැබැයි හරි ලේසි. හරි. හරිම ලේසි. Okay. Hi. So this is the content. This is the content of our paper. Okay. So unit number 3, waves and oscillation. Therefore, the main topic is unit number 3, waves and oscillations. Then we can simply write the content of paper. අපිට එනවා MCQs, approximately 9 MCQs, approximately 9 MCQs, structured this way. Definitely there will be one structured this way. And essay. There will be one essay question. For 9 MCQs, we will have 9 marks in the final paper. For the structured essay question, we will have 5 marks, and essay questions we will have 7.5 marks. Altogether, 21.5 marks. This is an approximate number, Bhuti. This is an approximate number, but this will not be varied with a large scale. Sometimes it may be 20, 22. Okay, so this is an approximate figure. Okay, then the unit content. We can divide this unit into 3 major categories. First one is oscillations. Then waves. Then light. Waves means waves and waves properties. All the features related to waves categorized under this category. Okay. So this is the content and this is the content of the unit and the content of the paper. The first topic, the main topic is unit 3, waves and oscillations. Then the paper content and the unit content. මේක මාරම ලේසි මේ යුනිට් එක මාරම ලේසි යුනිට් එකක් කියලා කියන්නේ සාමාන්‍යයෙන් මැතමැටිකල් පාර්ට් එක තියෙන්නේ අපිට ගොඩක් වෙලාවට ඔය මේකේ විතරයි පුතේ මොකද මේ දැන් අපි කරන සිම්පල් හාමොනික් මොෂන්ස් වල විතරයි හරි ඊළඟට තව බොහොම කියන්නේ තව මැත්ස් පාර්ට් එකක් තියෙන බොහොම සිම්පල් මැත්ස් පාර්ට් එකක් විතරයි ඊට පස්සේ අපිට ආයෙ හම්බ වෙන්නේ අපිට simple harmonic motion වල සාමාන්‍යයෙන් අපි අර mechanics වල හම්බුනා වගේම match part එකක් හම්බ වෙනවා. හරි. එතනින් match part එක ඉවරයි. ඊට පස්සේ තනි කරලා තියෙන්නේ theory ටිකක් විතරයි. හරිම ලේසි ඒ නිසා theory ටික හරියටම concepts ටික හරියටම මේ ඔයාලා understand කරගත්තොත් මේක මාර වේගෙන් cover කරන්න පුළුවන් lesson එකක්. හරි. ඊළඟට පොඩ්ඩක් වෙලා යන්නේ light වල lights කියලා කියන්නේ ගොඩක් වෙලාවට අපිට මේ වඳින්න තියෙනවා රේ ඩයග්‍රෑම්ස් වලින් තියෙනවා තරන්දරට එකත් එක්ක ලයිට්ස් වලට තමයි ඊට පස්සේ පොඩි ටයිම් එකක් යන්නේ ඒ වුණාම waves and oscillations කියලා කියන්නේ උන simple unit එකක්. Okay, shall I erase? Shall I erase? Okay with it. Then write a main topic. Then write a main topic oscillations. Oscillations. Okay, then another topic, the next subtopic is simple harmonic motion. Simple harmonic motion. Okay. Please listen to me very carefully. Simple harmonic motion is a mathematical part. Okay. Actually, math students can learn this lesson in math syllabus too. So this is a mathematical part. Okay. Actually, you have to understand this lessons very, very careful. Actually, we will have one MCQ or two MCQs using this in this lesson. Okay. Actually, but the thing is, this lesson is a mathematical lesson. හරියට understand කරගන්න ඕනේ. සමහර වෙලාවට සමහර ටයිම් වල වැරදි දේවල් කියන්න දැන් තියෙනවා. හරි. ඒ වගේ දේවල් මට කලින් අහුණා ඔය එක අවුරුද්දක ළඟ ඔය ගෙනාවා. මේක සිංහලෙන් කියන්නේ සරලනුවති චලිතය. සරලනුවති චලිතය ගැන කතා කරද්දී ඔක යාර එක විදියට ඩිෆයින් කරලා තිබ්බා මොකද්ද? සරලතාවක් ඔස්සේ සිදුවන අනුවර්ති චලිතයක් කියලා. ඒ සිංහලෙන්. ඒක වැරදි දෙයක් නේද? මේක සරල එකක් ඔස්සේ සිදුවන චලිතයක් නෙවෙයි. සරල එකක් ස්ට්‍රේට් ලයින් එකක් ඔස්සේ සිදුවන චලිතයක් නෙවෙයි. මොකද ඒක ඉංග්‍රීසි වර්ඩ් එක ගත්තොත් ඒක පැහැදිලිව. හරිද? එහෙනම් මේක ඉංග්‍රීසි වර්ඩ් එක ගත්තොත් පුතේ එහෙනම් ලීනියර් කැලලක් තියෙන්නද? එහෙම දෙයක් නෑ නේද? Simple harmonic motion. So this is simple harmonic motion. We will learn the definition. We will learn the definition and we will learn the characteristic of simple harmonic motion. Actually, this part is a easy part. Okay? It's an easy part. But the thing is, there are some mathematical equations. You have to remember those equations. You have to deal with the equations. So you have to understand the basic very carefully. Okay. Today I am going to discuss the basic concepts of this of simple harmonic motion. Therefore, please listen to me very carefully. If you have any question, please let me know. Okay. Because this you have to understand the basic concept of simple harmonic motion very well. Otherwise, most of the students may try to remember the equations. Okay. Then they will have a problem with it. And if you are going to remember the equation, actually you have to remember the equation. And you have to remember the equation. But if you are going to remember the equations only, then you cannot answer for some high level, that means advanced questions. So You have to understand this this lessons very carefully. This is a very easy, actually this is a easy theory part. Theory part is easy. Theory part is easy. Have I hurried up? Understand correct? No. Okay. Simple harmonic motion. Actually, we know our lesson is waves, no? Our lesson is waves, no? So, but the thing is, before we learn about waves, we are going to learn about simple harmonic motion. So, what is the reason for that? Can anyone guess? Our lesson is waves. Actually, our main topic is waves. But before we starting to learn waves, now we are going to learn about simple harmonic motion. Simple harmonic motion, that is an oscillation. Okay, why? So, what is the reason for that? Can anyone imagine? You know about, I think you know about mechanical waves and electromagnetic waves, no? Mechanical waves, I think you may learn this one in all of us. Mechanical waves. Mechanical waves. Okay, so mechanical waves means suppose to propagate a wave, if any wave requires a medium, or medium means if any wave requires some particles to propagate from one place to another place, that kind of waves are called mechanical waves. Okay. You know about transverse and longitudinal waves with it. So transverse and longitudinal waves are categorized under mechanical waves. And so mechanical waves means the waves that requires a medium to propagate from one place to another. Okay. So if I consider, or if I take a mechanical wave, it can be divided into two major categories. One is transverse wave. Other one is longitudinal wave. Transverse and longitudinal waves. And so in a transverse wave, actually we can create a transverse wave by vibrating particles perpendicular to the direction of wave propagation. And වරදක් කරලා ඇති. හරිද? දැන් අපි ගත්තොත් එහෙම මේක පෙන්නන්න බෑ පොඩ්ඩක්. හරිද? Okay, suppose this is a stretch string. So if I vibrate this string, what can you see? If I vibrate this string, what can you see? You can see a wave, no? You can see a wave, no? You can see a wave, no? Actually, I'm vibrating perpendicular to this wave. Perpendicular to this wave, no? And then there will be a wave. So that kind of waves are called transverse wave. So if the particle in the medium, vibrate perpendicular to the direction of wave propagation, that kind of wave are called transverse wave. So if we consider about transverse wave, this is something like this. So suppose this is this. Suppose this is the string. And මොකද කරන්නේ මේ string එක? Vibrate කරන්නේ. Okay. Suppose now this is the string. So if I vibrate this string, then what will happen? This kind of wave is propagated. No? Vibration. Therefore, if I consider about a particle, on that medium, if I consider about the particle on that medium, that particle vibrates about a fixed point. This particle vibrates around this point. This particle, when the wave propagates, this particle vibrates. So in transverse wave, when the wave propagates, the particles in that medium vibrates, oscillates about a fixed point. About a fixed point. Did you get my point? Actually, this happens in longitudinal waves too. And how to produce a longitudinal wave? Suppose some slinky. Actually, slinky we can demonstrate a longitudinal wave from a slinky booth. Okay. So to produce a longitudinal wave, we have to vibrate the medium into the direction of wave propagation. Okay. We have to vibrate the medium into the direction of wave propagation. Okay. Anyway, we have to vibrate the medium. So if I vibrate the medium, then there will be a wave with it in this direction. How to vibrate this medium? I have to vibrate this medium about fixed point. I have to vibrate this medium about a fixed point. Okay? I have to vibrate this medium about a fixed point. I have to vibrate this particle about a fixed point. Then there will be a longitudinal wave. Okay. And my concern is this. Either in transverse or longitudinal waves, when they propagate, what will happen? When they propagate, the particles in that medium vibrates about a fixed point. The particle vibrates about a fixed point to take. Okay. Either in perpendicular direction or parallel direction. In any direction, the particle vibrates about a fixed point. Did you get my point? Vibration means it is a periodic motion. Periodic motion means that motion occurs again and again. It is a periodic motion. That motion occurs again and again. Okay. So that kind of motions are called harmonic motions. Harmonic motions. Okay. That means when mechanical waves propagate through a medium, particles of that medium move in a harmonic motion, or they will oscillate. So that is the reason we are going to learn about oscillations before waves. And because we have to understand what is the motion of that particle. So that is the reason we are going to learn about simple harmonic motions. Did you get my point? Okay. We can write down that thing there. Okay. Simple harmonic motion, no? Simple harmonic motion. So, do you have any questions? Questions, Tinal today? No. All right. Then write under the topic. If a wave requires if a wave requires Kirshan, do you have any question for that? Do you have any question? Okay. If a wave requires a medium to propagate, a medium to propagate, a medium to propagate, come on, that kind of waves are called mechanical waves. That kind of waves are called mechanical waves. Mechanical waves can be divided into two major categories. Okay. You can do this one. Mechanical waves, transverse and longitudinal. Transverse wave, if it is a transverse wave, wave propagation is if the wave propagation is in this direction, particle oscillate perpendicular to the wave propagation. If it is a longitudinal wave, when it propagates, particle vibrate parallel to the wave propagation. I'm not going to describe that thing, but the thing is, I need that factor. What is the factor? When a mechanical wave propagates, particle in the medium vibrates about a fixed point. That means it is an oscillation. Okay. No, it is only a oscillation, but it is not a wave. It is not a wave. It is just oscillation. මෙතන එනර්ජි එක ට්‍රාන්ස්මිට් වෙනවා ඍෂික. ඒක මම ඒ එනර්ජි ට්‍රාන්ස්මිට් වෙන ප්‍රොසීඩියර් එක මම කියන්නම්. කොහොමද වෙන්නේ කියලා. ඒක අපි දැන් වේව්ස් කතා කරනකොට කියන්නේ. මේක එනර්ජි එක ට්‍රාන්ස්මිට් වෙනවා. හරි. ට්‍රාන්ස්මිට් නොවේ තියෙන්නේ එනර්ජි එක. එනර්ජි ට්‍රාන්ස්මිට් වෙනවා කොහොමද වෙන්නේ කියලා මම ඔස්සිලේෂන්ස් වලදී කියන්නේ. මේ සෝරි වේව්ස් වලදී කතා කරන්නම්. හරි. ඒක වෙනම ප්‍රොසීඩියර් එක. හරි. මට දැනට මෙතනට ඕනි අර විතරයි කියලා දෙන්නේ. මොකද්ද? wave එක propagate වෙනකොට particles vibrate about a fixed point. That is the only thing. හරිද? Okay. Write under that. Write under that. Therefore, therefore, when a mechanical wave propagates through a medium, when a mechanical wave propagates through a medium, comma, particles of that medium particles of that medium move about a fixed position. Yes. There is an application to it. So what's my last sentence?
Therefore, when a mechanical wave propagates through a medium, the particle of that medium move about a fixed position.
Okay. Such motions are called oscillations. Such motions are called oscillations. Such motions are called oscillations. Prior to that, oscillations are periodic motions. Oscillations are periodic motion. Periodic motions. Therefore, Therefore, such motion is referred such motion is referred as harmonic motion. Harmonic motion. Such motion is referred as harmonic motion. Underline this thing, harmonic motion. Okay. Okay, now can you give me some example for periodic motions? Hmm? Can you give me some examples for periodic motion?
Yeah.
I need the motion. The motion.
Vibration and oscillation.
Sorry, Pratik?
Can you explain the vibration?
Your sound is may actually sound is very low.
What's the vib-
Not clear. These two, not clear. Can anyone give me some example? Give me some example.
So a pendulum.
Yeah, pendulum. There's an example. Motion of a pendulum. అయితే ఈయన వాళ్ళు ఉంచగాల కన్నా ఆసామం కన్నా సెల్లు ఒకద్దు not about vibration and oscillations has me same terms with them. And there is a difference between a simple oscillation and a simple harmonic motion. And I will teach, okay? Jumping on. ඒක දාසාව විතර ඔස්සේ. Okay. I swing. Swing. Motion opposite. Up. Yeah, same motion. Right. Yeah, yo-yo ball. Yo-yo ball. Yo-yo ball. No. Actually, I mean today, I need a motion today. I need more motion. So due to a harmonic motion or due to a periodic motion, then definitely there will be a wave propagation. But I'm not asking about that. I'm asking about the motion. Okay. What are the examples of periodic motions? Hey, revolutions of what? Around the sun? Matter. Yeah, revolving, revolving, revolving. Club hands. Yeah, it can be taken. It can be taken. Sound mean putih? No. Sound means it is a result of a periodic motion putih. Sound means it is a result of a periodic motion. My question is, what are the examples for periodic motion? And sound, waves, then such kind of things are the result of a periodic motion. That is not a periodic motion. Huh? Waves, those are not a periodic motion. That is a result of a periodic motion. And yeah, another one. Revolving of the earth around the sun. Make a engine piston. Engine piston motion of an engine piston. And yeah, clock car. Yeah, that's also okay. Revolving of a clock car. Okay, examples of periodic motions. Wind turbine fans. Okay. Repeat again. Come on. Shall I erase? Okay. Then I have a topic. There are topic. Mechanism of an oscillation. Mechanism of an oscillation. Mechanism of an oscillation. So this is a part we have to understand very, very carefully. So please listen to me very carefully. If you have any questions, please let me know. Okay. මේ හොඳට තේරුම් ගන්න ඕනේ කරදරයක් පුතේ මේක තමයි බේසික් එක. මේක තමයි බේසික් එක. ඔය අමාරු questions ඕන එකක් ගන්න පුළුවන් බේසික් එක දුන්න. හරි. Okay. Look at this one. Now I'm going to describe the mechanism of an oscillation. How does it happen? Right. Look at this one. Suppose there's a spring and a weight is suspended by this spring. And a weight is suspended by this spring. And so once the weight suspended by this spring, now this system is in an equilibrium condition. Now this is in an equilibrium condition. So this is the equilibrium level. So this level is the equilibrium level, equilibrium position. Okay. suppose now I am going to apply a force, or I am going to pull this mass into the downward direction. Now I am going to pull this mass into downward direction. Please listen to me very carefully. Okay. Now tell me, when the mass is pulled in downward direction, now tell me the direction of force exerted on the spring and the direction of force exerted on the mass. Can anyone see? Can anyone tell? Mass එක පපල්ලට blue කරනකොට මොකද වෙන්නේ forces වලට? So what is the direction of force exerted on the mass and the spring? Listen to me very carefully. Okay, once I pull or once I stretch this string into downward direction, okay? That means if I apply a force, suppose if I apply a pull out force on this mass in downward direction, now I'm going to stretch this string in downward direction. So that means this string is stretched in downward direction. Therefore, the force exerted on this string should be into the downward direction. It should be stretched into the downward direction. Therefore, the force on the string should be in downward direction. It should be in downward direction. Therefore, the force on the spring should be on downward direction. Actually, this force is exerted by this mass, because mass is the object which is attached to the spring. So once I may pull out the mass is the object. So this mass pull this spring in downward direction. This mass pulls this spring in downward direction. Therefore, this force is exerted by this mass. So according to Newton's third law, an equal and opposite force should be exerted on this mass. Everyone, I need your responses. Okay. Therefore, those are the forces acting on this mass. Then now I stretch. Now I have applied some force into downward direction, and due to that force, this spring is displaced some displacement, some amount from this equilibrium position. Initial, this is the equilibrium position, this is the equilibrium position. Therefore, to change the current position from the equilibrium position, definitely I have to apply a force. I have to apply external force. Otherwise, I cannot change the equilibrium position. So if you want to change the equilibrium position, if you want to change the position of an object from its equilibrium position, definitely you have to apply a force. Okay. Initially, this object was at equilibrium position. To change the position, I have applied a force. So due to this force, the particle has displaced some amount from the equilibrium position. And so due to this force, due to this applied force, due to this additional force, there will be a pull-out force. Pull-out force on this spring. According to Newton's third law, there will be a reaction force on this mass. Okay. Now I am going to release this spring. If I release this spring, then what will happen suddenly? If I release this mass, this spring, if I release this mass, then what will happen? Then this force, this pull-out force will be zero. No, it will be disappear. No, this pull-out force, because now I'm going to release that object. So if I release this object, suddenly this force will be disappeared. But this force is there. So due to this force, definitely there will be a movement into the upward direction, Puti. Due to this force. And after that, this force will be may vary. But initially, once I release, this force will be disappeared. Then definitely there will be an external unbalanced force into the upward direction. Due to that force, this object is start to move in upward direction. Now this object is start to move in upward direction. Start to move in upward direction. Did you get my point? Everyone, I need your responses. Did you get my point? Okay. Then now this object moves in upward direction. So once this object comes to the equilibrium position, this object will have a velocity. This object will have a velocity. This object will have a velocity. So due to this velocity, this object won't stop at this equilibrium position because it has a velocity. Therefore, this object moves in upward direction. So when the object moves in upward direction, then what will happen? This is spring compressed, no? This is spring will compress. This is spring will compress. Then as a result of this compression, definitely there will be a force into the other side. Now this object compress the spring in this direction. This object compress the spring in this direction. Therefore, spring applies a reaction force into the downward direction. Therefore, after this point, the direction of force changes. Okay. Now the direction of force is in this direction. Direction of force on this object changed into the other side. I am winning. What is the reason? This object compressed the spring in upward direction. Therefore, the force on the spring is in upward direction, Puti. And therefore, according to Newton's third law, this spring will apply a reaction force on this object in downward direction. Therefore, the force on this object now change into the downward direction. Did you get my point? මොකක්ද උනේ කියලා මෙතනට මේ පැත්තට තිබ්බ ෆෝස් එක මොකද උනේ කම්ප්‍රෙස් වෙන්න ගත්ත ගාම පුතේ අනිත් පැත්තට ආවා බලන්න ෆෝස් එක වෙනස් වෙන විදිය බලන්න ෆෝස් එක වෙනස් වෙන විදිය හරිද මෙයා ස්ට්‍රෙච් නම් වෙලා තියෙන්නේ ස්ට්‍රෙච් එකක් නම් වෙලා තියෙන්නේ ස්ට්‍රෙච් එක නිසා බලන්න මෙයාව පල්ලෙහාට අදින්නේ ස්පින් එක පල්ලෙහාට අදින්නේ ස්ට්‍රෙච් එකක් නම් ස්පින් එක පල්ලෙහාට අද්ද ගමන් මෙයාගේ ෆෝස් එක තියෙන පුතේ ඔබ්ජෙක්ට් එක මත තියෙන ෆෝස් එක තියෙන්නේ උඩට. Therefore, force on the object was in upward direction. මම මෙතන ඔක්කොම effect කියලා ගත්තම මේ වෙනස් වෙනවා. එකම F නෙවෙයි තියෙන්නේ. හරි. So after this point, what will happen? The spring compress by this object. As a result of that, there will be a reaction force into the downward direction on this object. Vibration. Today, I am discussing the mechanism of oscillation. So what is about vibration? Huh? What is about vibration? I don't understand. What is your question? Tell me vibration again. My topic is mechanism of oscillation today. Vibration එකක් කියලා කියන vibration එක oscillation එක අතර තියෙන ලොකු වෙනසක් නැහැ. එකම දේ අර rate එක. අපි දැන් vibration එකක් ගත්තොත් vibration එක සාමාන්‍ය vibration එකක් කියලා නිකන් කියලා කියන්නේ මේ අර rate එක වැඩි වෙනවා. oscillation එකක් ගත්තොත් එහෙම සාමාන්‍ය oscillation එකක් ගත්තොත් ඒක rate එක වැඩි වුණත් කියලා සාමාන්‍ය oscillations වෙන්නේ සාමාන්‍ය අයිඩෝලා rate එක අඩු එච්චරම. හරි. එහෙනම් මෙතන තියෙන්නේ vibration එකක් වේවා oscillation එකක් වේවා තියෙන method එකක්මයි. හරි. Oh, yes. You have to maintain separate book today. You have to maintain separate book for unit number 3. Hurry. You have to maintain a separate book for each unit. Hurry. Hurry. Okay. I will discuss. I will explain it again. Okay. Look at this one. Tama ඉවරයි this explain කරලා. Tama ඉවර නැහැ මම මෙතනට නම් තේරුම් ගන්න විතරයි හැව්වේ. මම ඊළඟට කියන්නම් කොහොමද මේකේ අර oscillation එක වෙන්නේ කියලා. Okay. හරි. Look at this one. Now the object moves in upward direction. But the force is in downward direction. So due to this force, the acceleration should be in downward direction. Therefore, into the upward direction, there should be a deceleration. Therefore, this object should be decelerated into the upward direction. Okay. So this object will move up to the zero velocity level. Then it will move again in downward direction. Okay. Therefore, as a result of this velocity, this object will not stop at this position. It will move in upward direction. It will move in upward direction. When it go to the upward, when it move beyond the equilibrium position, then the force, the direction of force changes. So due to that change, there will be a deceleration into the moving direction. Due to this deceleration, the velocity decreases. Then this object moves until the kinetic energy or velocity zero level होते. Then this is the velocity zero level. Then again, it is start to moving downward direction. Start moving downward direction. And when it start moving downward direction, then what will happen? Then up to this position, it will come in gravity. And then after that, after this one, after that point, then again, when the object comes to this position, again, it will have a velocity. So due to this reason, it won't stop at the equilibrium position. It won't stop at the equilibrium position. It will move in downward direction. Once the object moves in downward direction, then again, this scenario will apply. Okay. Again, it will move in the upward direction. Then again, this scenario will be applied. And ඔන්නෝක තමයි වෙන oscillation එක. ඔන්නෝක තමයි වෙන periodic motion එක. This motion will continue until the energy stored in this object becomes zero. Okay. Because once I stretch this object, once I stretch this spring, then definitely some energy was stored in this object with it. So this object will move until the total energy becomes zero. Did you get my point? Suppose this is a now this is a simple pendulum. Now this is the equilibrium point with it. This is the equilibrium point. Then I have pulled this object from the equilibrium point and release. What will happen? This will what will happen? This pendulum oscillate some periods, and after the stored energy becomes zero, or if the stored energy is fully occupied, then the object comes to the initial equilibrium point. Initial equilibrium point energy zero. Otherwise, it will move up and down. Okay. Did you get my point? Or now I select my explain karana.
Excuse me, sir.
Yes, Pute. Yes, Pute.
Stationary waves.
Pute, I didn't hear your question, Pute. The stationary waves mean I will define that. I will define because if I define that one today, then I have to explain that one for a long time. And it will take some time. Actually, it will take time. And I will define. Okay, my care. Hi. Okay. Do you have any questions regarding this? Regarding this, make any more questions, you know? Do you have any questions regarding this? Devi, Hamda, Krishya, Yanusha, is you? No. So this is the mechanism of oscillations today. In this case, you have to understand very carefully these things. The first one is the presence of equilibrium position. The presence of equilibrium position. Initially, the object was at equilibrium position. Okay. Then if there is oscillations, definitely this object should be moved from its equilibrium position. Okay. How to move that? How to move the object? To move the object, we have to apply an external force or additional force. We have to apply an additional force with it. And so we have to apply an additional force to move this object from its equilibrium position. Therefore, to have oscillation, initially the object should be at the equilibrium position. Then we should apply a force, an external force on that object. This is very easy if you think this as a swing. Swing එක විදිහට හිතන්න. ඔන්න යාළුවා ඇවිල්ලා ස්වින් එකේ ඉඳ ගන්නවා. මොකද කරන්නේ ස්වින් එක කරකවන්න ඕන නම්? මොකද කරන්නේ? යාළුවා ඇවිල්ලා ඉඳගත්තට පස්සේ අදිනවා පස්සට. පස්සට දාලා අතාරිනවනේ. This is just like that. හරිද? You can think this as a motion of swing. Okay. So if you want to move a swing, what should I do? Once the person sit on the swing, then I have to pull. I have to pull him back. No? Then what should I do then? Then I have to release him. Okay? Once I release him, he will oscillate. No, he will oscillate. Okay? He will oscillate until the given energy becomes zero. Until the given energy becomes zero. The same thing. So how to actually create oscillation? How to create an oscillation? The first thing, there should be an equilibrium position there. So from that equilibrium position, we have to apply an external force. Then what should I do? I have to release that external force. I have to release that external force. So once I release the external force, look at this force diagram. If I release the external force, definitely there will be a force on this object into the upward direction. Using this force, this object starts to move in upward direction. How does swing the car? Swing the gadala, then what will happen to the object once it comes to the equilibrium position? What will happen? It will have a velocity. Swing the car, swing the car. එයා පල්ලෙහා level එකට එනකොට මොකද වෙන්නේ? It has a velocity. It has a velocity. So due to that velocity, it won't stop at the equilibrium position. It will move in upward direction. So in in upward direction. Once this object moves in upward direction, what will happen? This object compress this spring. Therefore, the force on the spring is in upward direction. According to Newton's third law, the force on this object is in downward direction. Therefore, the force on the object, the direction of force on the object reverse is reverse. හරියට ස්වින් එක උඩ යනවා වගේ. ස්වින් එක මෙතනට එනකන් ආවා වේගෙන් ඊට පස්සේ උඩ යනකොට මොකද වෙන්නේ? ෆෝස් එක තියෙන්නේ පුතේ පල්ලෙහාට ග්‍රැවිටි එක පැත්තට. යන්න එතකොට හිමින්ස් හරි ස්වින් එක යන්නේ හිමින්ස් හරි ගිහිල්ලා උඩ යනවා කියන්නේ. නැතිලා එනවා. ඒක තමයි. So once due to this force, due to this downward force, this object moves in a deceleration mode. Therefore, the velocity of this object decreases with time. So this object moves until the velocity becomes 0. Yes. In this case, පුතේ මොකක්ද? Elastic potential energy of this spring converted into the is converted into the kinetic energy. හරි? There should be a energy conversion පුතේ. හරිද? ඒ conversion එක ඉතින් වෙන ඕන දෙයක් වෙන්න පුළුවන්. දැන් මම මෙතන ගත්ත එක හැටියට මෙතන elastic potential energy එක තමයි kinetic energy එකක් වෙන්නේ. හරි? හැම වෙලේම මේක කියලා හිතන්න එපා. මේක මොකද මේ horizontal movements තියෙන්න පුළුවන්. Horizontally, there should be a horizontal simple harmonic motions puti. Therefore, energy conversion can be any form puti. Then what will happen? So once the velocity gets 0, then this object start moving downward direction due to the gravity. So once the object comes to the initial equilibrium position, then it will have a velocity in downward direction. Therefore, this object won't stop at the equilibrium position. And then it moves in downward direction. Then again, this scenario will occur. Okay. This will be a periodic scenario or periodic occurrence today. So actually this is very much similar means actually that is the motion of a swing. That is the motion of a swing. And මොකද්ද මේ කියලා බලන්න swing එකක් move කරන්න ඕන නම් මම මොකද කරන්න ඕන? If you want to move a swing, what should I do? Definitely, I have to pull the swing from its equilibrium position. Okay? I have to pull back the swing from its equilibrium position. Then I have to release the force. Once I release the force, swing will start to move up and down. What will happen? Then? It will move here and there. Then it will come to the initial equilibrium position once the given energy becomes 0 or fully occulted. Okay. අපි මේක අඳගමු පුතේ. Yes, sir. we can explain the propagation of waves using simple harmonic motion. Actually, that is very effective explanation. Waves phenomenon lazy explain waves phase difference simple harmonic motion particles particles එක වෙලාවට simple harmonic motions පටන් ගන්නෙ. එතකොට එහෙම හිතුවොත් එහෙම මාර ලේසියෙන් waves තේරුම් ගන්න පුළුවන්. හරි ලේසියි. ඒක මම කියපේ හරියට මම understand කරගන්න පුළුවන්. This one, first figure, figure 1, figure 2. Figure 3, figure 4, 5, 6, 7. Okay, they write on this. Write on this. Number one. First point. Number one means this relates to figure number one. This relates to figure number one. Right under that, let's consider a scenario. Let's consider a scenario. Let's consider a scenario where a certain mass is suspended from a spring. As mentioned in the figure 1, the object is in the equilibrium condition. The object is in the equilibrium condition. The object is in the equilibrium condition. Then number two raised to figure number 2. Number 2. Okay. Now, come on. Now, let's consider. Let's consider a situation. Let's consider a situation. Let's consider a situation where the object is pulled, where the object is pulled where the object is pulled now the object is pulled a certain distance, a certain distance, a certain distance away from its equilibrium position. A certain distance away from its equilibrium position. As the object moves in downward direction, as the object moves in downward direction,
Sir, can you repeat that last part you said?
as the object moves in downward direction, as the object moves in downward direction, it exerts exerts it exerts a force downward on this spring. It exerts a force downward on this spring. In response, comma, in response, the spring in response the spring exerts an equal and opposite force, an equal and opposite force, an equal and opposite force an equal and opposite force upward on the object, upward on the object. You can do this. Look at this one. The force on the spring is in downward direction. The force on the object is in upward direction. Okay. This is the third one. Third and fourth. देखो मेरे पास लिया third का fourth एक बार लिया 3 and 4. Third and fourth explanations. Now, if we release the force, sorry, now, if we release the object, not the force taken part. Now, if we release the object, the force we applied within the bracket speed, the force we applied the force agree with it. So within the brackets speed, the force we applied disappears. As a result, an unbalanced force, an unbalanced force acts upward on the object, upward on the object. And upward on the object. This causes the object the object to try to return to its equilibrium position, to return to its equilibrium position. This causes the object to try to return to its equilibrium position. Even though, oh, sorry, writing another para, even though the object returns to the equilibrium position, even though the object returns to the equilibrium position, it still has velocity. It still has velocity. It still has velocity at that moment. At that moment. at that moment. Therefore, the object does not stop at the equilibrium position. Okay, then number 5 and 6. Then number 5 and 6. Prior to that, then the object continues. Then the object continues. The object continues to move upward direction. Upward direction beyond the equilibrium position. Then the object continues to move upward direction beyond the equilibrium position. Then the object compress the spring. Then the object compress the spring. As a result of that, the object exerts a force on the spring in upward direction, while the reaction force on the object is in downward direction. Okay, right on that. That means the direction of unbalanced force, the direction of the unbalanced force on the object is reversed. Right on that. Due to this downward force, the object decelerates in upward direction. Okay, I will repeat it again. Ganesha, from which point to the?
So while the reaction force on the object is in downward direction, from that part to due to this downward force, the object decelerates the last one. Yeah.
Can anyone repeat that sentence with it?
It's fine. So then maybe I just missed one part. That's fine. Sir. That's fine.
It's okay.
It's okay. Sir. It's okay. I can understand.
Okay. Then write in another para. Then The object moves. The object moves until the velocity becomes zero. Until the velocity becomes zero. Then it starts to move in downward direction. It starts to move in downward direction. Okay. Then the figure number 7. Then the point number 7. Point number 7 again. Figure number 7. And the last one. After that, the object after that, the object moves back to the equilibrium position. Moves back to the equilibrium position. But is still, sorry, but it is still has velocity. But it is still has velocity as it reach to the equilibrium position. As it reach to the equilibrium position. Therefore, it cannot stop it cannot stop at the equilibrium position. It cannot stop at the equilibrium position. So it moves again, it moves again, it moves again. Moves again downward beyond the equilibrium position. It moves again downward beyond the equilibrium position. Look at this one, Budek. This is figure number 8. If you have enough space, please draw this figure too. This is figure number 8. So now this object moves in downward direction. So once the object moves in downward direction, what will happen? This spring will stretch again. It will stretch again. So as a result of that, there will be a force on the spring in downward direction. No, to stretch the spring, we have to apply force on downward direction. And therefore, the force on the spring is in downward direction. Therefore, according to Newton's third law, the reaction force on this object is in upward direction. It is in upward direction. Look at this side. Again, so until this position, the force is in downward direction. Until that position the force is in downward direction. But after that, what happens? After that, again, the direction of force is changed. It is reverse. Now again, the direction is in upward direction. As in the figure number 3. Now the force is in upward direction, but the object moves in downward direction. Force is in upward direction. Therefore, force is in upward direction means acceleration is in upward direction. Therefore, towards the downward direction, there should be a deceleration. Therefore, this object decelerates in downward direction. As a result of that, the velocity decreases with time, and it will become 0 after some time. Okay. Did you get my point? Did you get my point? Everyone, I need to respond. So after some time it will become 0, but force is in upward direction. Then, so after getting 0 velocity, then it will start to move in upward direction. because the force is in upward direction. Then it comes again to this location and it will go beyond this position. Once it goes beyond that position, the force will be reversed. Then again, this will happen. So this is a periodic motion. This is a periodic motion. This will happen until the total energy in that object becomes zero. Did you get my explanation? Explanation එක තේරුණාද? මට හැමෝගෙම ඕනි මොකක්ද උනේ කියලා. මේක තමයි පුතේ එතකොට oscillations කියලා කියන්නේ. නැත්නම් vibrations කියලා කියන්නේ ඔන්න ඔක තමයි. හරිද? Did you get my point? Thank you. Hamda. Devi පුතේ. හරිද? Okay. Okay. Then please draw this image with the image number 8. Image number 8. Atente para list. Alright. Write down, write down, write it as now. Now the next point is point number 8. Point number 8 means this refers the figure number 8. Once the object moves in downward direction, beyond the equilibrium point, beyond the equilibrium position, once the object moves in downward direction, beyond the equilibrium position, the object stretches the spring again. The object stretches the spring again. As a result of that, a force is exerted. A force is exerted downward on the stream. The force is exerted on the force is exerted downward on the stream. Therefore, the reaction force on the object, is in upward direction. As a result of that, the object decelerates in downward direction. The object decelerates in downward direction. බලන්න පුතේ මෙයාගේ මුළු motion එකම deceleration එකක්. motion එකම deceleration එකක්. Decelerates in downward direction until the velocity becomes zero. Until the velocity becomes zero. Until the velocity becomes zero. Full stop. But as there's a force in upward direction, the object moves again in upward direction. The object moves again in the upward direction. Okay, right under that, put it right on that. This is a new paragraph. Therefore, this is a periodic motion. This is a periodic motion. So this is a periodic motion. In this manner, come on. So in this manner, the object oscillates the object oscillates back and forth around the equilibrium position, In this manner, the object oscillates back and forth around the equilibrium position. Okay. Right under that. This referred to as oscillations or periodic motions. Oscillations within the brackets harmonic motions. Oscillations within the brackets harmonic motions or periodic motions. This referred to as oscillations within the bracket harmonic motions, close the bracket, or periodic motions. Now, this is the mechanism of oscillations. If you fully understood this concept, then it will very easy to solve advanced questions with it. And because there may be sometimes there may be some advanced questions with it. Something I will explain as an example with it. But if you understood this concept, it is very easy to get answers with it. Right. Now tell me, I need answers from everyone. Okay? But answers I need answers from everyone. Now tell me. So what could be the reason? What would be the reason to have oscillation? oscillation එකක් එන්න හේතුවක් වෙන්න පුළුවන්. So what would be the reason to have an oscillation? Now tell me. You can turn your pages and look into the explanations and tell me what would be the reason to have an oscillations or periodic motion. අනේ වචනින් ගන්න පුළුවන් නම් හොඳක් please. So if there is a periodic motion, what is the reason to have such motion? Yeah, there's the correct answer. There's the correct answer. Among your answers, there's the correct, exactly correct answer. Accurate answer එක තක තිබ්බා. මම කියන්නේ අනිත් අයට answers දෙන්න. What is the reason? Hand up. Ashini? Oh, Hamda, Ashini? Anita, Malmi? This true? මට ආන්සර් එකක් දෙන්න පුතේ. ඒක ආන්සර් එක වැදුනට කමන්නේ ආන්සර් එකක් දෙන්න. මට ආන්සර් එකක් දෙන්න කියලා කියන්නේ නිකන් ඔය කියනවා නේ. මක්ක ලොජික් එකක් එක්ක දෙන්න. පුතේ, this should be a periodic motion පුතේ. නේද? This is a periodic motion. So after releasing the object, this object should be repeated its motion. The object should repeat that motion. To repeat that motion, what should be the factor? What should be the factor to repeat that motion? Look at the factor. What should be the factor? Okay. හරි. Answers දෙකක් ආවා. මොකද්ද? There should be an external force. නේ? There should be an unbalanced external force. Yes. හරිද? Otherwise it cannot go towards the equilibrium position. In every moment, the object goes into the equilibrium position. So what is the reason for that motion? Actually, there was an unbalanced force. No, there are always there was an unbalanced force acting on the object. So due to the unbalanced force, this object move towards the equilibrium position. But the thing is, at the equilibrium position, it had a velocity. Due to that velocity, it cannot stop the motion at the equilibrium position. Then it moves beyond the equilibrium position. then again there's a force. Then again there's external force acting towards the equilibrium position. Due to that force, the object decelerates and it stops its motion. Then again it comes to the equilibrium position. But it cannot stop the motion because it had a velocity. So due to velocity, it passes the equilibrium position again. Once it passes the equilibrium position again, there's an unbalanced force acting on that object. Therefore, that unbalanced force acting on that object is the factor to have that oscillation. And did you get my point? ඔය unbalanced force එක නැත්තම් මේ වැඩේ කරන්න බෑ. ඒ නිසා හොඳට මතක තියාගන්න ඔයාලට මොන question එකක් දුන්නත් සමහර වෙලාවට ඔයාලට exam එකේදී දෙන්න පුළුවන් එක විදිහේ questions පුතේ. ඔයාලා හරියටම මීටරෙන් understand කරගත්තා නම් මෙන්න මේක තමයි unbalanced force එක කියලා ගන්න හදන්න පුළුවන්. එච්චරමයි දැනගන්න ඕනේ. එච්චරමයි ඔයා grab කරගන්න ඕනේ. බලන්න දීලා තියෙන question එක ඒ question එකේ හැටියට බලන්න මොකක්ද මෙයාගේ unbalanced force එක. If you can understand what is the unbalanced force, then definitely you can get the answer. And මේක තමයි සාමාන්‍ය advanced questions වලදී ඕනේ. මම කියන්න අපි කරලා හරි. නිසා හොඳට මතක තියාගන්න මම මේක කියන්නේ මම මේ ලාවට අල්ලනව නෙවෙයි මේ ක්‍රිෂ් පාඩම. ලාවට අල්ලනව නෙවෙයි හරියටම මම කියා දෙන්න පුතේ හරිම logic එකක් එක මම කියා දෙන්නේ. මේ logic එක හැම වෙලෙම හුරු වෙන්න. මොකද මේකේ තියෙන equations පුරේ 100ක් විතර. හරි. ඔය equations එක කටපාඩම් කරන්න ගියොත් ජීවිතේට මේක උඩ යන්නේ නැහැ. හැබැයි හරියට මේක තේරුම් ගන්න පුළුවන් වුණොත් equation ටික ටක් ගාලා මතක් වෙනවා. ඒක අමතක වෙන්නේ නැහැ ටක් ගාලා මතක් වෙනවා equations ටික. මොකද අපි logic එකත් එක්කනේ පුතේ පාඩම් කරන්නේ. logic එකක් එක පාඩම් කරනවා ටක් ගාලා equation ටික ඔලුවට එනවා. හරි. ඒක එකක් අනික equations ටික අපිට හරියට manage කරගන්න පුළුවන්. මේ දෙවෙනි කාරණේ හරියට බැරි වෙලා හරි අමතක වුණොත් ටක් ගාලා ඩිරයිව් කරගන්න පුළුවන්. මොකද ඩෙරිවේෂන් එච්චර වෙලා යන්නේ නැහැ. ටක් ගාලා ඩිරයිව් කරගන්න. හරි. ඒක නිසා equation එකක් වුණා ටක් ගාලා ඩිරයිව් කරගන්න පුළුවන්. හරියට fully understanding හිටියොත්. හරි ඒක මම කියන්නේ මාර ලේසි පාඩම. හැබැයි හරියටම තේරුම් ගන්න. හරියටම තේරුම් ගන්න ඕනේ. කටපාඩම් කරන්න පුළුවන්. කරන්න පුළුවන් සීමාවක් තියෙනවා. ඒක. ඒක මම කියන්නේ කටපාඩම් කරගෙන තමයි හරියටම ඒක point wise මම මේක මෙච්චර වෙලා අරගෙන explain කරේ ඒකයි. මෙච්චර වෙලා අරගෙන මේ explain කරේ ඒකයි. හරියටම ඕගොල්ලන්ට ඔළුවට දෙන්න මොකද්ද මේකේ තියෙන reason එක කියලා. මොකද මට මේක ඕනි ඉස්සරහට මගේ advanced applications වලට කතා කරන්න. හරි. එහෙම නැත්තම් නිකන් උඩින් පල්ලෙන් ආවලා equations ටික දුන්නොත් එහෙම අර හිතන්න පුළුවන් ළමයා කරගෙන යයි. නමුත් අන්තිමට logic එකක් නැහැ. හරි. ඒ නිසා හැම වෙලෙම මෙතනින් ඉස්සරහට එන ඔක්කොම theoretical part එකක් තියෙන්නේ. මේක තමයි mathematical part එක තියෙන්නේ. මතක තියාගන්න හැම වෙලෙම logically හැම වෙලෙම හිතන්න. මෙන්න මේක නිසා තමයි මේක වෙන්නේ. logically හැම වෙලෙම හිතන්න. හරි ලේසි වැඩි අරන් යන්න. හරි. මේ equations මතක තියාගන්න එක ප්‍රශ්නයක් නෙවෙයි. මතක තියාගන්න ඒක ටක් දාලා ගන්න හදන්න පුළුවන්. හැබැයි කටපාඩම් කරලා වැඩි කරන්න යන්න එපා. ටිකක් එතකොට අමාරු වෙනවා පුතේ. මේ කටපාඩම් කරනකොට කීයක් කටපාඩම් කරන්නේ? නේද? දැන් මේ බයෝ කරන ළමෙක් ගත්තොත් එහෙම එයාගේ මුළු ජීවිතේම කටපාඩම් කරන්න ඉතින් බයෝ පුළුවන් කටපාඩම් කරන්න ඕනේ. කෙමිස්ට්‍රි පාඩම් කරගන්න ඕනේ. ඒතර ෆිසිකල් පාඩම් කරන්න ගියා ජීවිතයක් නැහැ ඉතින්. ඒ නිසා logically තේරුම් අරගෙන මතක තියාගන්න ඕනේ. logical තේරුම් ගන්න හිතත් හරිය ලේසි වැඩේ කරන්න. හරි. Okay. Do you have any questions regarding that? Amount එක තේරුණා? පැහැදිලිද? මෙතන නිකන් පැහැදිලිද? Okay. හරි. එහෙනම් අපි දාගමු factors ටික. හරිද? දැන් මේක oscillation එකක් වුණේ ඇයි කියලා දාගමු. හරිද? Okay. Then I have a topic. the factors required for oscillation. Okay, so if there's an oscillation, initially we have to do a part. So initially we have to pull the object from its equilibrium position, then we have released that one. That should be done. So after doing that action, to maintain the oscillation, to maintain the periodic motion, definitely the factor should be that unbalanced force. But to start the motion, then definitely we have to give a displacement. We have to give displacement from the initial starting point, initial equilibrium point. Okay. So I'm going to mention that factor 2, but the thing is, it is for starting the oscillation. Oscillation is start but after that, to maintain the oscillation, there should be only one factor, that is the force. Okay. Try on that. Factor number one. First factor. The presence of an equilibrium position. 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 Number 2. The displacement caused by an external force. The displacement caused by an external force applied to the object from its equilibrium position. Correct. Look at this one. Look at these two factors. What is the first factor? Definitely there should be an equilibrium position today. So after that, there should be a displacement. There should be a displacement from the equilibrium position. And there should be a displacement from the equilibrium position. So those two factors are required to start the oscillation. Things are made factors are going to make oscillation to start an oscillation. To start an oscillation, we have to have these two factors. Then the third and most important factor. This factor is required to maintain the oscillation. What is the third factor? The unbalanced force. The unbalanced force. The unbalanced force on the object towards the equilibrium position. The unbalanced force on the object towards the equilibrium position. So that factor is required to maintain the oscillation. That factor is required to maintain the oscillation. පැහැදිලිද? සරිද? Now we can get a small break today. Now it is 10 past 10. You can have a 20 minutes break today. Other local break and then about 20 minutes break. So please come at 10:30. Please come at 10:30. Now you can take a break today. Okay, shall we start? Up to now we have discussed what is an oscillation and what is the mechanism of oscillation. And okay, now we are going to discuss about characteristic of oscillations. Now, final topic, characteristic of oscillations. Characteristic of oscillation. Okay. Today, if I draw the previous oscillation again, suppose this is the equilibrium position. So if this is the equilibrium position, okay, you remember this is the equilibrium position thing. Equilibrium position. So in this case, the object moves in upward direction. This case, upward and downward. Okay. Moving direction in upward and downward. Math upward and downward. and up and downward development. So it is upward movement and downward. Okay. In oscillation, this can move upward and again it can move downward. Upward and downward. Okay. So during this oscillation, from here to here means suppose this position is A, this position is B, this position is C. From A to B, the unbalanced external force is directed towards the upward direction. I think you can remember that thing. Then from B to C, the unbalanced force is directed to downward direction. Okay. Therefore, look at this one. Therefore, throughout the motion, the unbalanced external force directed towards the equilibrium point, towards the equilibrium point. Okay, from A to B is directed towards the equilibrium point. From B to C, it is directed towards the equilibrium point. Therefore, in an oscillation, the unbalanced force is always directed towards the equilibrium position. Did you get my point? I have read it. Thank you. So this is the first characteristic. Characteristic number 1. Draw this one. මේ graph එක මේකට හදගන්න බලන්න පුතේ මේකට. Look at this one. Everyone, please look at the board. Okay. So stop drawing. Please look at the board again. Okay. මේකට එත් එක හදගන්න එක. Look at this one. This is the second one, second characteristic. Okay. Pute, in oscillation, displacement of the object, is measured with respect to the equilibrium position. So you know, actually when we were discussing about linear motion, to measure a displacement or velocity, we have to define a starting point and positive direction. We have defined a starting point and a positive direction. So we have to do that thing in this case too. So as a general practice, the displacement of the object is always measured with respect to equilibrium point. and with respect to equilibrium point. So look at this one. So if I measure the displacement, if the object is in this side, that means if the object is below the below the equilibrium point, the displacement is in this direction. The displacement is in this direction. So when the object is in upward direction, the displacement is in upward direction. Displacement is in upward direction. Displacement is in upward direction. Look at this one. Okay. Now force is in so in this case, force is in upward direction and direction is in downward direction. Displacement is in downward direction. So in this case, force is in downward direction while the displacement is in upward direction. What can you say? What can you say? The displacement measured from the equilibrium position and the force is always in opposite directions. They are always in opposite direction. And did you get my point? පැහැදිලිද? එහෙනම් මේක බලන්න. අද අපි මේ simple harmonic motion එකේ පුතේ ඒ කියන්නේ වැදගත්ම ටික අද කවර් වෙනවා. ඒ නිසා අද මිස්සුනොත් එතනින් එහාට simple harmonic motion අල්ලගන්න බෑ. හරි ඒක තමයි මම කිව්වේ ඕගලන්ට අර රූපයෙන් දැන් මේක පටන් ගන්නකොටම දැන් රෙකෝඩින් බලන කට්ටියම මම දන්නේ මම මෙතනින් පස්සේ මම රෙකෝඩින් අප්ලෝඩ් දෙන්නේ කෙලින්ම සයිට් එකට. සයිට් එක ගන්න රෙකෝඩින්ස් බලන්න බෑ. මම මාසයක් විතර තිස්සේ මම සැප්තැම්බර් පටන් ගන්නදී මම නෝටිස් එකක් දුන්නා බැලන්ස් රෙකෝඩින්ස් තියනවා බලලා ඉවර කරන්න. බැලන්ස් රෙකෝඩින්ස් තියනවා බලලා ඉවර කරන්න බැලන්ස් නම් තියාගන්න එපා. ආයි මගෙන් ඉල්ලන්න එපා. හරි. මොකද ඒක ඔයාලගෙන් හොඳට මම කරේ. එහෙම නැත්නම් ආයි තව මාස 6කින් 7කින් තමයි නැටත දෙවෙන්නේ කරලා නැහැ නේ. හරි. ඕක අයින් කරන්න තමයි මම මේ දැම්මම මේ වැඩේ ස්ට්‍රික්ට් කරේ. ඒ නිසා ආයේ කලින් රෙකෝඩින්ස් කරන මගෙන් ඉල්ලන්න එපා. කලින් රෙකෝඩින්ස් නැහැ දැන් මා ගාවත් නැහැ. හරිද? මේ මෙතනින් පස්සේ අනිවාර්ය රෙකෝඩින්ස් යන්නේ පුතේ වෙබ්සයිට් එකට. වෙබ්සයිට් එකට ගිහිල්ලා එතකොට බලන්න පුළුවන්. ඒකත් වීක් කැප් විතරයි වැලිඩ් වෙන්නේ. හරිද? ඒ නිසා අනිවාර්යෙන් හැම වෙලෙම එදිනදා වැඩ කරන ළමෙක්ට විතරයි රැඳිලා ඉන්න පුළුවන් වෙන්නේ. හරිද? එදිනදා වැඩ කරන ළමෙක් තමයි රඳව ගන්නත් ඕනේ. නැත්නම් බෑනේ. මේ ඒ කියන්නේ මෙතනින් පස්සේ නම් පොඩ්ඩක් සෙල්ලම් කරන්න දෙන්න ටිකක් අමාරුයි. හරිද? අමාරුයි කියලා කියන්නේ හේතු කිහිපයක් උඩ මේ නැත්තම් පසුව අපිටම තමයි චෝදනා වෙන්නේ මේ ළමයි ගැන බැලුවේ නැහැ. හරිද? ඒක වලක්ක ගන්න තමයි ඉතින් මේ කරන්නේ. හරි. මේ හොඳයි. වැඩේ හරියටම යන ළමයි කීයද ඉන්නේ ඒ කීප දෙනා තමයි මගේ නම් එක්ක යන බලාපොරොත්තු තියෙන්නේ. හරිද? ඒ නිසා මාගෙත් එක්ක මගේ විදියට ඒ වැඩේ කරගෙන යන කට්ටියක් තමයි ඉතින් ගෙනියන්න වෙන්නේ. මේක මම ගියත් ගෲප් එකේ නිකන් ඉන්න ළමයි කීප දෙනෙක් කියන්නේ මෙලෝ තේරුම් ගන්න තියෙන ළමයි කීප දෙනෙක් අයින් කරලා දෙම වැඩක් නැහැ පුතේ කියන්නේ අඩු ගන්න රෙකෝඩින් එකක් කියලානවා නම් ඒත් මම රෙකෝඩින් එකක් කියලා නෙත් නැහැ ලයිව් ක්ලාස් එකෙත් නැහැ රෙකෝඩින් බලන්නෙත් නැහැ මේ දැන් ඔය එකක්වත් නැත්තම් ඉතින් ඊළඟ ඉඳලා වැඩක් නැහැ හරි මේ ඉතින් එතනින් පස්සේ ඒ සෙල්ලම් ගහම එතනින් පස්සේ කොහොමද ඒ සෙල්ලම් ගහ මේ කවුරුත් හරි කාට හරි මිස් වුණොත් සතියක් ඇතුළත එයාට පුළුවන් රෙකෝඩින් එක කම්ප්ලීට් කරගන්න ඒක මම අප්ලෝඩ් කරනවා මේ මොකක්ද අපේ සයිට් එකට හරි ඒක නිසා මේ ආයි අපේ ගෲප් එකේ මම රෙකෝඩින් ෂෙයා කරන්නේ නැහැ අවශ්‍ය රෙකෝඩින් එකක් තියෙනවා නම් ඒ කියන්නේ වැදගත් වෙයි කියලා හිතන රෙකෝඩින් එකක් තියෙනවා නම් මම ෂෙයා කරනවා ගෲප් එකේ මම ඒක ෂෙයා කරා මේ දර්ශනා කරේ මම එහෙම කියලා මම ෂෙයා කරේ මේ වෙන හේතුවක් නිසා නෙවෙයි මොකද ගිය සතියේ මම තිබ්බේ එක්ස්ට්‍රා ක්ලාස් එකක් අපි ලොකු වෙලාවක් කරා ඒ වගේ එකක් මිස් වුණොත් මම එක්ට ටිකක් අමාරුයි අල්ලගන්න හරිද ඔය කියන කතන්දරේ එක තමයි මම මේ ෆ්‍රයිඩේ ක්ලාස් එකේ මම ෂෙයා කරේ ඒ නිසාම තමයි අද මම මේ අලුත් පාඩම පටන් ගත්තේ ෆ්‍රයිඩේ අපි කර ඉතු පාඩම පොඩ්ඩක් පැත්තකට තියලා මේ ඒක අපි ආශාවක් නෙක්ස්ට් ෆ්‍රයිඩේ වෙනකන් දැම්මෙත් ළමයිට රෙකෝඩින්ස් බලලා කවර් කරගන්න පුළුවන් වෙනවා. ඒ ඔයාලගේ පැත්තෙන් හැම දෙයක්ම ඒ විදිහට හිතද්දී ඔයාලත් පොඩ්ඩක් අනිත් පැත්තට හිතන්න ඕනි සහ ඔයාලගේ පැත්තෙන් වෙන දේවල් මට හරියටම කරන්න ඕනේ. එහෙම නැතුව ඉතින් අදගෙන යන ටික අමාරුයිනේ පුතේ. මේ හොඳට මතක තියාගන්න අර continuously වැඩේ කෙරෙන්න ඕන මට. يعني ක්ලාස් එන එක සහ රෙකෝඩින් බලන එක continuously වෙන්න ඕන. හරි. ඒක හොඳට මතක තියාගන්න. එහෙම නැත්නම් ටිකක් අමාරු විදිහට අල්ලගන්න. තරමේ අමාරු අල්ලගන්න. හරි. මොකද මේ අර සිලබස් එක දැක්ක ගමන් ඔක්කොම ටික මේ ඔළුවට යන જાති කවුරුත් නැහැ නේද? ඒක කාටවත් කරන්න අමාරුයි. ඒ නිසා ඉගෙන ගන්න ඕනේ කියන්නේ ඕන වෙලකදී අපි ස්ටඩි කරන්න ඕනේ මේ අර ක්ලාසස් වල තියෙන ඒවා අහන්න ඕනේ ඒවා ඔක්කොම ගියාට පස්සේ තමයි අපි හැමෝටම ඔය ඔක්කොම ටික අන්ඩර්ස්ටෑන්ඩ් වෙන්නේ හරිද එහෙම නැතුව නිකන් එන්නේ නැහැ නේද ඒ නිසා මේ වැඩ කරන්න ඕනේ හරිද ඊළඟට මම අද මම පේපර් ක්ලාස් ගෲප් එකට මට දාන්න බැන්නා මම දාන්නම් මේ ක්ලාස් එක වෙලා මේ වීක් එකේ ඉඳලා මම කිව්වා පේපර් ක්ලාස් එක යන්නේ පුතේ රිවිෂන් එකක් විදිහට කියලා කියන්නේ අපි මැකැනික්ස් වල තියෙන questions අපි කරනවා. අපි මේ වීක් එකේ මම බැලුවාද static questions ටික. static and මේ vectors questions ටික තමයි අද කරන්න මම බැලුවේ. ඒ වගේ questions කරලා මේ වීක් එක මුසල් මේ වීක් එකේ මේ month එක ගත්තොත් මේ month එක දිගටම ඒ විදිහට කරලා මේ next month එකේ ඉඳලා next month එකේ මම ඔයගොල්ලන්ට කිව්වා මම වෙනම අපි term test එකක් යනවා term test එකක් තියෙනවා ඒක වෙනම තියෙනවා ඊට පස්සේ දිගටම ඔයාලට උදේ එක සතියකට එක full paper එක ගානේ හම්බ වෙනවා එක සතියකට එක full paper එක ගානේ හම්බ වෙනවා කරා එහෙම plan එකක් තමයි මම ඔළුවේ තියෙන්නේ මොකද මුල ටික revision එක කරන්න නැතුව පේපර් එක දීලා තේරුමක් නැති වෙයි කියලා මට හිතුණා මොකද මේ සමහර වෙලාවට ළමයින්ට අමතක වෙලා තියෙන්න පුළුවන් දැන්ටත් අමතක වෙලා ඇති ඉතින් ගොඩක් ළමයි ටික හරි ඒ නිසා මේක පොඩ්ඩක් මේ අපි රීකැප් එකක් විදිහට පොඩ්ඩක් මෙමරයිස් කරන්න ඕනේ ඒක නිසා මේ මුල් පාඩම් ටික මේ විදිහට අපි පේපර් ක්ලාස් එකේදී අයසරක් රිවිෂන් එකක් විදිහට මම බලනවා මගේ මේ Thursday ඔයාලට පේපර් ක්ලාස් එකක් මම arrange කරන්න බලනවා මේ සතිය ඉඳලම එතකොට Thursday එකයි මේ Sunday එකයි දෙකක් හොඳයි මට ඒක මේ මාසේ කරගන්න ඕනේ කියලා කියන්නේ මේ මාසය ඇතුළත පුළුවන් තරම් අර රිවිෂන් එක කරගන්න ඕන නිසා ඔයාලට රිවයිස් කියන්නේ පහුගිය පාඩම් ටිකයි මතක් කරගන්න ඕන නිසා මම බැලුවේ තර්ස්ඩේ එකයි සටර්ඩේ එකයි දෙකම දාගන්න මේ වීක් එකේ ඉඳලම මම ඒක ඉන්ෆෝම් කරන්න හරියටම කන්ෆර්ම් නැහැ ඒක. එහෙම වුණොත් එහෙම ක්ලාසස් අපිට 8ක් විතර කව වෙනවනේ. එහෙම වුණොත් මේ අපිට මේ ක්වෙස්චන්ස් ගොඩක් කරගන්න පුළුවන්. ක්ලාසස් එන්න බැරුණා කියලා ප්‍රශ්නයක් නෑ. මොකද අපි වෙබ් ක්ලාස් එකක් නිසා මේ එහෙම ඉන්න බැරි ළමයිට අක්කාලා මගෙන් මේ රෙකෝඩින් එක ඉල්ල ගන්න. හරිද? රෙකෝඩින් එක ඉල්ල ගන්න පුතේ. ඔකද එහෙම මම රෙකෝඩින් මේ පේපර් ක්ලාස් එකේ රෙකෝඩින්ස් මම එවනවා. පේපර් ක්ලාස් එක අරගයි පටලව ගන්න එපා. පේපර් ක්ලාස් එකේ රෙකෝඩින් එක මම පේපර් ක්ලාස් ගෲප් එකේ මම දානවා. මේ ඒක නිසා ඒක මේ කිසිදු ප්‍රශ්නයක් කරගන්න එපා. මේ මොකද පේපර් ක්ලාස් එක අනිවාර්යෙන් ළමෙක් ඒක අනිවාර්යෙන් කරන්න ඕනේ. මේ ඒක අනිවාර්යෙන් දානවා. ඒක මේ මාසෙම මම අනිවාර්යෙන් ඒක දානවා. රිවිෂන් එකක් විදිහට යන නිසා. එතකොට පුතේ මේ මොකද්ද මෙතනින් කියන්නේ මේ මාසේ මම පුළුවන් තරම් try කරන්නේ අපි යාන්ත්‍රික විද්‍යාව නැත්නම් මැකනික්ස් වල අපිට අපි කලින් කරපු සහ මේ දැන්ට අමතක වෙලා තියෙයි කියලා හිතන ඒ theory parts ටිකෙන් කියන්නේ questions කරන්න. හරි exam එකට ආපු questions ඊට පස්සේ අපි කරපු questions කරන්න තමයි මම බලාපොරොත්තු වෙන්නේ. විශේෂයෙන්ම essay තමයි මම වැඩිපුරම ටාගට් කරන්නේ. හරි මේ ඒක නිසා පොඩ්ඩක් ඒක තවදාන යොමු කරලා පොඩ්ඩක් ඔයාලත් ස්ටඩි කරලා තියාගන්න. නැත්තම් මේ ස්ටඩි කරලා නැතුව ඉන්න එපා. තේරුම් ගන්න නැහැ නෝ කියලා. මේ අද ස්ටඩි පාර්ට් එක අපි අද කරන්නේ ස්ටඩි පාර්ට් එක සහ වෙක්ටර්ස් කියන දෙක. හරිද? ඒකත් එතනදී අපි කරපු වගේම ක්වෙස්චන්ස් ටිකක් අපි කරලා තියෙනවා. මොකද අපි EQR එකක් කරපු නිසා ආයසරයක් අහුවේ. ඉතින් අපි මම කිව්වා ආයසරයක් අහු වෙනවා කියලා. ආය පාරක් අහුවේ ක්වෙස්චන්ස් වල. හැබැයි ඒකෙන් ආයසරයක් අපි මතක් වෙයි ඕගොල්ලන්ට අපි කරපු ටෙක්නික්ස් ගත්ත මොනවද කියලා. හරි? 8:30 පුතේ 8:30 මේ මොකක්ද ඒ විදිහට තමයි යන්නේ ආයසරයක් මේ තර්ස්ඩේත් 8 to 8:30 වගේ තමයි පටන් ගන්න වෙන්නේ. මේ මොකක්ද තර්ස්ඩේත් අපි අද කරගන්න පුළුවන් වුණොත් මේ ස්ටඩි පාර්ට් එක තර්ස්ඩේ එකක් නැහැ නැත්නම් තර්ස්ඩේත් ස්ටඩික්ම තමයි කරන්න වෙන්නේ. මේ මොකක්ද එහෙම වුණොත් පුතේ මේ ඊළඟට ඔය ටිකත් එක්කම ඔය දවස් දෙකයි මම යූස් කරනවා ප්‍රැක්ටිකල්ස් ටික කවර් කරන්න. ප්‍රැක්ටිකල්ස් ටික අපි తీරණය කරන්න. ප්‍රැක්ටිකල්ස් ටික කවර් කරන්නත් මම ওই දවස් දෙක යූස් කරනවා. ඒතරදී එන්න බැරි නම් රෙකෝඩින්ග්ස් මම දෙනවා ළමයිට. එන්න බැරි නම් රෙකෝඩින්ග්ස් දෙනවා ළමයිට. ඊට පස්සේ අපිට next month වල අපි සාමාන්‍ය කරගත්තොත් එහෙම next month මැද ඉඳන් වගේ අපිට පුළුවන් කෙලින්ම full papers වලට මම ප්‍රැක්ටිස් කරන්න තු full papers දෙන්න බෑ පුතේ. ප්‍රැක්ටිකල්ස් ටික ඔයාලට කියා දීලා ප්‍රැක්ටිකල්ස් වලින් එන questions අපි කරලා තමයි full paper එකට යන්න වෙන්නේ. මේ එතකොට next month මැද වෙයි කොහොමද full paper එක එනකොට. මේ next month මැද ඉඳන් දිගටම එතකොට full papers අපිට හම්බ වෙනවා. ඔයාලට නොකර ඉන්න බෑ කරන්න ඕන කරලා මට ඒවන්න මම බලන්න. හරිද? මම බැලුවා කියලා කියන්නේ අනිවාර්යයෙන් අපි ඩිස්කස් කරන්න ඕනි ඩිස්කෂන් එකවත් බලන්න. හරි? මේ මොකද දිගටම අපි ටයිම් කරලා පේපර්ස් කරන්න ඕනේ. මට දැන් මෙතන තියෙන එකම කතන්දරේ මේක ඔන්ලයින් ක්ලාස් එකක්. ඔන්ලයින් ක්ලාස් එකකදී දැන් අපි වෙනම මේ ෆිසිකල් සෙන්ටර්ස් නැහැනේ පුතේ. එතකොට ඔයාලගේ තියෙන මේ අමංකභාවය තමයි ඉතින් තනිකරම මේකේ පදාපවතින්නේ. තමුන් හරියට දීලා තියෙන වෙලාවට දීලා තියෙන විදිහට කරන්න පුළුවන් ප්‍රෙෂර්ස් ගන්න දීලා තියෙන වෙලාවට කරලා තියෙනවා. එතනින් එහා කරන්න එපා. එතනින් එහා කරන්න වෙනම රෆ් ෂීට් එක වෙනම කරත් කමක් නැහැ. වෙනම කරන්න. හරිද? මේ පේපර්ස් ටික කරන්න ඔයාලා වෙනම කියන්නේ ෆුල් පේපර්ස් ගන්න වෙනම එකක් තියාගන්න. මේ විතර අපි කොහොමද මේ රිවිව් එකක් කරන්න පුතේ. මේ ඒ නිසා මොකක්ද full paper එක කියන්නේ MCQ structured and essay content. හරි. දැන් අපිට කරලා තියෙන ටික තමයි අපි කරන්නේ. හරි. ඒ කියන්නේ තාපයත් heat එක්කම heat lesson එකත් එක්කම කරන්නේ. හරි. heat lesson එකත් එක්කම කරන්නේ පුතේ මේ එතකොට ඒකත් ඔයාලා දැන් අපි production එක කරලානේ තියෙන්නේ. ඒත් නිකන් ඔයාලගේ ඒකත් උඩු තියෙන්න ඕනේ. දැන් එතකොට අපිට කවර් කරන්න තියෙනවා අරද මේ ප්‍රැක්ටිකල්ස් එක කවර් කරන්න තියෙනවා අපි අර මැකැනික්ස් වල මේ මැකැනික්ස් වල ටිකයි මේ මුලින් අර මෙෂන් ඉන්ස්ට්‍රුමන්ට් ටිකයි ඊළඟට මෙතන මේ හීට් වල ප්‍රැක්ටිකල්ස් අපි කද්ද බෙද කරා මේ ඊට පස්සේ ඉතුරු තව එකක් තියෙනවා මේ කරන්න ඒක කවර් කරන්න ඕන හරිද මේ ඒ ටික කවර් වෙලා තමයි එතකොට ඕනම පේපර් එක හැදෙන්නේ හරි ඒ නිසා මේ ඉන්ෆර්මේෂන් එක මම දුන්න ඔයාලට ඉන්නඩස් දුන්නේ කොහොමද යන්නේ කියලා අපි මුලින් අර වගේ රිවිෂන් එක ගිහිල්ලා රිවිෂන් එකෙන් පස්සේ තමයි ප්‍රැක්ටිකල්ස් ටික කරන්න ගන්න. හරි. හොඳයි. අපි ඒක බලමු. හරි. Okay. I finish. හරි. They write this under the figure. Write this under the figure. Topic is characteristic. Topic is characteristic of oscillations. Topic, characteristic of oscillations. Okay. Right under this, the unbalanced force. The unbalanced force. The unbalanced force. Caused by the external force. The unbalanced force caused by the external force is always directed towards the equilibrium position. Towards the equilibrium position. Number 2, second characteristic. The displacement from the equilibrium position. The displacement from the equilibrium position. And the external force are always in the opposite directions. Are always in the opposite directions. Sharu. Okay, Putin. Look at the board again. Okay, look at the board again. Look at this. Look at this. The unbalanced force. Look at the unbalanced force. The unbalanced force brings the object towards the equilibrium position. No, the unbalanced force always brings the force, brings the object towards the equilibrium position. Eh? So in this case, due to this unbalanced force, object moves towards the equilibrium position. So after that, it again moves to the equilibrium position due to the unbalanced force. Therefore, this unbalanced force brings the object towards the equilibrium position. It always brings the object towards the equilibrium position. Therefore, there's a very, very beautiful name for this unbalanced force, that is restoring force. Restoring force. Restoring force again. And restoring. Okay. So from this point onwards, we can use this word instead of unbalanced force. Restoring force. And restoring force. Okay. We can write that. It is as a way should. So please may write this as a special note, Puti. Special note. Note number one. Note number one. Note number one. Since the unbalanced force, since the unbalanced force always brings the object, always brings the object back to its equilibrium position, back to its equilibrium position. Back to its equilibrium position. It is referred to as a restoring force. Restoring force. Restoring force. Oh. Then the second note, note number 2. There's another word for equilibrium position. Okay. You can clearly notice the oscillation is actually this object oscillates about this equilibrium position. Therefore, this equilibrium position is called the center of oscillation. The center of oscillation. This is called the center of oscillation. It is another name. It is another name for equilibrium point. Center of oscillation. Equilibrium position. Equilibrium position. Equilibrium position is called the center of oscillation. Center of oscillation. Those are some special terms in simple harmonic motion. Do you have any questions up to now? Do you have any questions regarding simple harmonic motion up to now? Simple harmonic motion again. Questions clear cut. But I'm only responding to our but I would like to. Okay. Okay. Pute, actually, up to now, we have discussed about oscillations. What is oscillation and what is the mechanism of oscillation and what are the characteristics of oscillations and what are the factors that require to have oscillation. Those are the things we have discussed up to now. Those are oscillations. But our topic is simple harmonic motion. So simple harmonic motion is some special type of oscillations. Okay. Now we are going to study about simple harmonic motion, which is a special type of oscillation. Then write a topic: simple harmonic oscillations. Simple harmonic oscillations. Or in other words, simple harmonic motion. Simple harmonic motion, as a short term, we call it as SHN. Simple harmonic motion. अब SHN क्या करना है बस दिख रहा है Second characteristic means force and displacement. Put it. Now this is the equilibrium position. Those are the two places with respect to equilibrium position. So if the object is in downward direction, force is directed towards the equilibrium position. Force is directed towards the equilibrium position. Now force is in upward direction, but displacement should be measured from here to here. Displacement should be measured from here to here. Therefore, the direction of displacement is in downward direction, while the direction of force is in upward direction. So if we consider about this scenario, now the force, restoring force the restoring force is directed towards the equilibrium position. And now the displacement is in upward direction. No, if I measure the displacement, I should measure displacement from here to here, from the starting point to the end point. And so this is the starting point. And therefore, displacement is in upward direction while the force is in downward direction. Therefore, in simple harmonic, it's not simple harmonic motion. In oscillation, always the restoring force and the displacement are in opposite directions. Hello. Are you clear with that, Pute? Tagala. Okay. Now, X is displacement, Pute. X is the displacement. X නැත්තම් කිව්වම මොකක් හරි වෙන වචනයක් දාගන්න S කියලා. X means displacement. Displacement. X normally we call it as X හරි. X O S O Y O ඕන එක දාගන්න පුළුවන්. ඒ word එක නෙතන එපා. X means displacement. Okay. Yes. There are only two occasions. No, one is first one is it is under the equilibrium position. The second occasion is it is over the equilibrium position. Those are the only two main positions. So if it is under the equilibrium position, the force is in upward direction while the displacement in downward direction. If it is above the equilibrium position, force is in downward direction while the displacement in upward direction. Therefore, always they are in opposite direction. And there are only two positions. ඒක මම පෙන්නන්න. ඒක අපි මේ අපේ mathematical equation එකේ තමයි කතා කරන්නේ. හරි? equilibrium position එකේදී මොකක්ද එතන එන්නේ කියලා. හරි? ඒක මම කියන්න. ඒක ඉස්සරහට කියන්න. හරි? හරිද පුතේ තේරුණාද? හරි. Okay, then simple harmonic motion, simple harmonic oscillations. Normally we call it as SHM. SHM. Hal SHM. Now you know, as I respect me now, force and displacement. Force and displacement are in opposite direction. No, force and displacement are in opposite direction in an oscillation. If the magnitude of restoring force, we can write it as this symbol. This is a modular symbol. It says the magnitude of restoring force. If the magnitude of restoring force is directly proportional to the magnitude of displacement, then this kind of motions are called simple harmonic motion. Simple harmonic motion. So if I consider about F related proportional X, then I can convert this relationship into an equation using a proportionally constant. Proportionally constant. And okay, now F is equal kx puthe, but you know the direction of F and direction of X are in two opposite directions. So this is a vector equation puthe. Therefore, this force and this X are in opposite direction. Therefore, we have to use a negative mark in front of this terms puthe. So then I can say F is equal minus kx. F is equal minus kx. So if the restoring force of any oscillation follow this equation, then that kind of oscillations are called simple harmonic oscillations or simple harmonic motion. So this is the special characteristic of that particular motion. And so if there's oscillation that follows this relationship, then it will be a simple harmonic motion. And did you get my point? Okay. Yan ang pilihan. Yan ang gusto din ba? Write down under topic. If elastic potential energy එක පුතේ හැම වෙලේම එන්නේ ස්ප්‍රින් එකකනේ. හරිද? ස්ප්‍රින් එකයි මේ එතකොට ස්ප්‍රින් එකක් ගැන කතා කරද්දී elastic potential energy එකක් ඔයාලා කතා කරන්න වෙනවා. ඒ නිසා දැන් අපි මොකක් හරි simple harmonic motion එකක වුණත් elastic මේ ස්ප්‍රින් එකක් තියෙනවා නම් අන්න ස්ප්‍රින් එකක් තියෙන තැන ඔයාට එනවා අනිවාර්යෙන් elastic potential energy එක. හරිද? ඒ වගේ ස්ප්‍රින් එකක් වගේ මොකක් හරි අර elastic property තියෙන material එකක් තියෙනවා නම් විතරයි elastic potential energy එකක් එන්නේ. එහෙම නැත්නම් එන්නේ simple harmonic motion එකක් කියලා කියන්නේ හැම වෙලේම ස්ප්‍රින් එක motion එකක් නෙවෙයි පුතේ ස්ප්‍රින් එකක් නොවන simple harmonic motion ඕනි තරම් තියෙනවා. මම ගත්ත example එක ස්ප්‍රින් එකක්. එහෙම කියලා ස්ප්‍රින් එකක් විතරක් නෙවෙයි simple harmonic motion එකක් කියලා කියන්නේ. හරිද? ඕනි තරම් තියෙනවා. හරි ස්ප්‍රින් එකක් ආවොත් ස්ප්‍රින් එකට අදාළව elastic potential energy එකක් එන්නේ. එච්චරයි. ඒ හරියට නිත්‍යවට එන්නේ. Hello. Okay. Yeah, okay. Now you can write down this thing. If the magnitude of the restoring force, if the magnitude of the restoring force is directly proportional to the magnitude of displacement, is directly proportional to the magnitude of displacement. Okay, I will repeat it again. Okay? I will repeat it again. I will repeat it again. Write down another topic. The magnitude, sorry, if the magnitude of restoring force, if the magnitude of the restoring force, if the magnitude of the restoring force is directly proportional is directly proportional to the magnitude of to the magnitude of to the magnitude of the magnitude of displacement displacement the magnitude of displacement to the object, sorry, to the position of the object, to the position of the object from the equilibrium position, from the equilibrium position, from the equilibrium position. Equilibrium position means center of oscillation. Center of oscillation. Then the oscillation is known as simple harmonic motion. Simple harmonic motion. Okay. So this is the definition of simple harmonic motion. Therefore, I can write magnitude of restoring force is directly proportional to the displacement. The displacement. The magnitude of restoring force is directly proportional to the displacement. And ඒකෝන ගහන්න පුළුවන් මම පොඩක් අදින්න ඕන ඉතින් suppose this is the equilibrium position. Maybe spin like that. Okay. I know the force is in upward direction while the displacement is in downward direction. While the displacement is in downward direction. Okay. So displacement and forces are in two opposite direction. Then I can write this one again, right? I can write this relationship as F directly proportional to minus x. F directly proportional to minus x. Why I use this minus sign? Because F and x are in two opposite direction. Have two opposite direction. Therefore, I can say F. I can convert this into an equation. So if I convert this into equation, it is equal minus kx to be F equal minus kx. This is called the characteristic equation of simple harmonic motion. It is called the characteristic equation of simple harmonic motion. Okay. This is the characteristic equation. Where හරිද? Okay. They write under this. Write on this. මේ අපව දාගන්න මේ characteristic equation එක මම ඉතින් දාගන්න. Write under that. Since f and x are in opposite direction, since x and f are in opposite directions, says x and f and x are in opposite directions and both being vectors, a negative sign I will repeat it. A negative sign is included to the equation. A negative sign is included to the equation. I will repeat. A negative sign is included to the equation. Okay, I will repeat it again. Please check your sentence paragraph. Since f and x are in opposite directions, and both being vectors, a negative sign has to be included to the equation, or is included to you. Yes, Uday. Both the equations are characteristic equations, Uday. Both the equations are characteristic equation, but this is the definition. This is the definition. So this equations comes from the definition. The second equation, as you told you, the second equation we will derive that thing later. That also the characteristic equation. That also a characteristic equation. This is called the characteristic equation of simple harmonic motion. Characteristic equation of simple harmonic motion. මොකද අපිට characteristic equation දෙකක් ගන්නවා කියලා කියන්නේ ඒ දෙකම okay කියලා කියන පුතේ මේ අපි calculations වලට use කරන්නේ අර acceleration එක. මොකද force එකට වඩා acceleration එක තමයි අපි calculations වලට use කරන්නේ. හරි. Now you know F is equal minus kx. This is the characteristic equation. And okay, suppose now I'm going to apply F equal ma or Newton's second law to that object with it. So if I applying F equal ma to the object, then I can write m into a instead of force. M into a instead of force. Therefore, ma is equal minus kx to b. Minus kx. So if I divide this by a, if I subtract a is equal minus k over m into x. Minus k over m into x. Look at this one. K is a constant. This one is a constant. And you know the mass of the object will not be changed. That also constant. Therefore, this one is also constant. Both are constant. Therefore, k over m, this ratio should be a constant. This ratio should be a constant. Therefore, I can take it as another constant. Okay? So a is minus k dash x. So k dash means it is another constant. Therefore, k over m is a constant. I can take it as k dash as another constant. Therefore, a is a minus k dash x. K dash x. So not only acceleration, not only force, but also acceleration is in negative directive proportionality with x with it. And එහෙනම් ඒකත් directive proportionality එකක් තියෙන්නේ මෙතන. මේක මම ඊළඟ තව ඩිරයිව් කරන්න තව දෙයක් තියෙනවා. ඒක අපි ඊළඟට කතා කරනවා. නමුත් දැන් මෙතන මම කියනවා so acceleration also follows this characteristic equation. Okay. මේක බලන්න. So this one also a characteristic equation today, but after deriving this k dash is equal to omega squared. Therefore, after deriving that part, I will do that now. Hello. Shall I rest? We right topic. Third topic. Representation of a simple harmonic motion. Representation of a simple harmonic motion. Third topic. Representation of a simple harmonic motion. Representation of a simple harmonic motion. Within the brackets, correlation between simple harmonic motion and circular motion. Correlation between S, H, M and CM. Clear? Apa yang interesting part adalah okay. So, okay, topic is representation of a simple harmonic motion within the brackets. Correlation between simple harmonic motion and circular motion. Okay. Okay. Look at this. Suppose there's a object. This object moves in a circular path with a constant angular velocity. So if this object moves in this circle, we can consider the perpendicular projection of that object on y-axis. Look at this one. Suppose the perpendicular projection of this object on the y-axis. How to get the perpendicular projection? What is the perpendicular projection? Again. We have no perpendicular. Perpendicular projection again. Suppose a light beam. Suppose a light beam is incident from this side. On a light beam incident side. So like if the light beam is incident in this side, is incident in this side. Now take the shadow of this object on y-axis. So if you take the shadow of this object in y-axis, that is the perpendicular projection to it. So if you incident a parallel light beam to x-axis, then how to take the perpendicular projection? That means shadow. How to take shadow? Suppose this is a screen. Suppose this is the screen. So if this is a screen, then there is a shadow at this position. මෙන්න මෙතන shadow එක තියෙන්නේ. මෙයා shadow එක මෙන්න මෙතන තියෙන්නේ. අයි light beam එක මේ පැත්තේ. දැන් මෙයා මේ වගේ තැනක ඉන්නකොට මොකද? If the object is at this position, now the shadow means perpendicular projection. Perpendicular projection means this one is perpendicular to the y-axis. Now the shadow is on this position. If the object now look at this one. Now this object moves to the anti-clockwise direction. දැන් මෙයා මේ පැත්තට යනවා. මෙයා මේ පැත්තට යනවා. මෙයා මේ පැත්තට යනකොට මොකද වෙන්නේ? Look at this one. Initially the shadow was at this position. Initially the perpendicular projection was at this position. That means center. Okay. So while this object moves around the circle, this shadow means perpendicular projection, moves in upward direction. No, it moves in upward direction. In upward direction up to this location. And then suppose now the object is at this position. Now object is at this position. Now the perpendicular projection, how to get the perpendicular projection? You have to draw perpendicular. So why? You have to draw the perpendicular fact. That means this is the perpendicular projection. If the object is at this position, perpendicular is projection is that. If the object is at this position, perpendicular projection is this. Look at this one. Now object moves from here to here. Now the object which is moving in circular motion, moves from here to here. Suppose this one is A, this one is B. The circular motion, the object moves in the circular motion, move from A to B. Okay. While this object moves from A to B, the projection, the perpendicular projection moves from O to B. Then now this object moves in downward direction. Once this object moves in downward direction, what will happen to the perpendicular projection? Now it moves in downward direction. Look, initially this one is this position, now that position, after that this position, so after this position. Now this object moves in downward direction. Now the perpendicular projection moves in downward direction. Initially this one moves in upward direction, now the downward direction. Suppose the object is at this position. So if the object comes to this position, then the perpendicular projection comes to this level. Right? This level. Perpendicular projections come to this level. When the object comes to this position, perpendicular or projection comes to that position. Then now the object moves from here to here. So if the object comes to this position, again the perpendicular projection was at this position. Now it moves to this location. So once the object moving in circular motion comes to the position A, again circular motion, again the perpendicular projection comes to the center. මෙයා මෙහෙට යනකොට මෙයා මෙහෙ පල්ලෙහාට යනකොට මොකද වෙන්නේ? මෙයා මෙහෙ පල්ලෙහාට යනකොට projection එකක් මේ පල්ලෙහාට යනවා. Look at this one. The projection comes down. Then again projections moves in upward direction. Again the projection turn back and moves in upward direction and come to the original position again. Come to the original position again. That means when the object moves in a circular motion, its perpendicular projection moves in this kind of motion. That means O to B, B to O, O to C, and C to O. O to B, B to O, O to C, O to C to O. Then what will happen? Now this is an oscillation. This is not only a simple oscillation, that is a simple harmonic oscillation. We can prove that one. Did you get my point? Therefore, corresponding perpendicular projection on y-axis of an object which is moves in a circular motion shows a simple harmonic motion. Did you get my point? The explanation is there. Everyone, I need to explain. එහෙනම් තමයි. ඔගේ අනිත් පැත්තක් තියෙනවා. ඒ කියන්නේ අපි x axis එකක් ගන්න පුළුවන් වගේ දෙනවා. මේ පැත්තෙන් මම ප්‍රොජෙක්ෂන් එක ගත්තොත් එහෙම x axis එක මේ විදිහට යන්නේ. හරිද? ඒක ගන්නත් පුළුවන්. ඕන්න අපි එකක් ගමු. මම ගත්තොත් එහෙම නේද? මේ පැත්තෙන් ප්‍රොජෙක්ට් කරොත් මේ පැත්තෙන් මම ප්‍රොජෙක්ට් කරොත් මොකද වෙන්නේ? බලන්න. Now I can take the perpendicular projection on the x-axis. Okay. Initially the object was at this position. That means perpendicular projection also at this position. Then the perpendicular projection on x-axis. Now object moves to here, moves from here to here. Now projection moves from here to here. Projection moves from here to here. Now object moves from here to here. Now the projection moves from here to here. Now the object was at this position. Now projection should be at this position. That means projection should be at this position. Now look at this one. Now object moves from here to here. That means projection moves from here to here. Now the projection is at this position. Then the object moves from here to here. The projection is at this position. So it moves from here to here. So this is the projection. And so once the object is at this position, projection also at this position. So once the object moves from here, the projection again moves in this direction. Then again up to this direction, again up to this. That means not only the perpendicular projection on y-axis, but also the perpendicular projection on x-axis shows a simple harmonic motion. That means if I consider simply So this is a circular, this is an object which is moving in a circular motion. So if I consider the perpendicular projection on each axis, they show simple harmonic motion during the during the motion of this object. So as the object moves from here to here, this perpendicular motion moves from here to here and return back and come down and turn back and come to this position. This object moves from here to here, here to here, and up to this location. Then it turn back, come to the position of it. And maybe simple harmonic motion oscillation again. Therefore, we can represent a simple harmonic motion as the motion of perpendicular projection on y-axis or x-axis of an object which is moved in a circular motion. Circular motion object take when perpendicular projection became movement take a simple harmonic motion. Did you get my point? Okay. Then you can draw this one. Okay. Then write down this thing. Let's consider an object. Let's consider an object. Rotates in a circular motion. Rotates in a circular motion. Rotates in a circular motion with a constant angular speed. Okay? With a constant angular speed. Let's consider an object that rotates in a circular motion with a constant angular speed. Suppose two parallel light beams to y and x axis respectively to y and x-axis respectively. Now we can consider the perpendicular projection of the object on each axis. Okay, I will repeat it again. Second error. Suppose two parallel light beams. Suppose two parallel light beams to y and x-axis respectively. Then we can consider the perpendicular projection of the object on each axis. Within the brackets, perpendicular projection is equal to the shadow of the object on each axis. Perpendicular projection is equal to the shadow of the object on each axis. Close the bracket. Write in another para. It is very clear. When the object rotates in the circular motion, its shadows on y and x-axis. Its shadows on y and x-axis oscillate around the center of the circle, around the center of the circle. Therefore, it can be considered, therefore it can be considered that the perpendicular projections of the particle, the perpendicular projection of the particle therefore it can be considered that the perpendicular projection of the particle engage in circular motion, on the y and x axis are move in simple harmonic motion. On the y and x axis are move in simple harmonic motion. Okay. Therefore, it can be considered that the perpendicular projection of the particle engage in circular motion on the y and x axis are move in simple harmonic motion. Simple harmonic motions. Okay, with it. Then we can discuss the mathematical relationship in our next class, because if I start to do that, then it cannot be completed. Okay, anyway, we can write the topic. And instruct the class. Mathematical relationships in simple harmonic motion. Mathematical relationships in simple harmonic motion. So this is the most critical section in simple harmonic motion. Topic is mathematical relationships in simple harmonic motion. We are going to derive those equations. Okay. Then we are going to draw a lot of graphs. And so before you come to the next class, please watch or not watch, but please go through the trigonometric note. You have to remember the sine curves, cos curves. And you have to remember that thing, sine curve, cos curves. And then sign conventions for angles. Now I need those knowledge with it. And මට knowledge එක දැන් ඕනේ. හරිද? මැත්ස් කරන කට්ටියට නම් දැන් අවශ්‍ය විදිහට මැත්ස් කරන කට්ටිය දන්නවනේ. හැබැයි බල කරන කට්ටිය කියලා බලන්න sin curves, cos curves ඊළඟට මොනවද positive negative angles කිව්ව මොනවද? අන්න ඒවා පොඩ්ඩක් බලන්න මම කියා දීපු ඒවා ටික දැන් මට ඒ ටික ඕනේ වෙනවා. ඒ නිසා තමයි දවසට කියන්නේ. හරි. ඒ ටික ඕනේ මේ අපි ඊළඟ prove කරනකොට පුතේ එතකොට ඊළඟ මේ ක්ලාස් එක simple harmonic motion එක ඉවර වෙනවා. හරිද? questions ගන්න තියෙනවා. ඉවර වෙයි. හැබැයි ඒක තමයි simple harmonic motion එකේ තනි කරම අර නාදි ඉවර ගන්න බැලි මේ derivations ඉවර ගන්න වෙලාවනේ. හරි. දැන්ටත් මේක බැරි. තව 7 minutes 7 minutes නිකන් දැන්. හරි. ඒක නිසා derivation එක මම next week කරනවා. ඒක මාරම critical class එකක්. මාරම critical class එක නිසා මම ඔයාලට මේ කියන්නේ විස්තර ගන්න එපා. මොකද derivations ගත්තොත් මේක හරියටම අපි understand කරගත්තොත් වඩා ලේසි වැඩේට. හරිද? සමහර applications තියෙනවා. ඒ applications කොහොමද ඉන්නේ කියන දේ හරියටම understand කරගන්න ඕනේ. හරිද? ඒ නිසා next class එක ටිකක් critical concept එක. හරි. හොඳයි. So we can complete today's class with it. Do you have any questions up now? Do you have any questions up now regarding simple harmonic motion? Thank you. Then we will meet again tonight because we will have paper class with it. So today I'm not going to discuss a paper, but I'm going to give you an assignment. Okay, assignment means missed question regarding vectors and force equilibrium. Vectors and force equilibrium. That will be a MCQ paper. It will be MCQ paper because if we consider about our A-level paper, those theory part will be used to prepare MCQ questions for it. And අපේ සාමාන්‍යයෙන් essay questions එනවා අඩුයි. අර දෙකේ ඇවිල්ලා නැහැ. හරිද? ඒනවා අඩුයි. ඒ නිසා ඒකේ තනිකරම අපි MCQ පැත්ත තමයි එතනදී අපි බලන්නේ. හරි. Okay. Please be prepared. Okay. So everyone then have a nice day. I want to welcome.
Thank you, sir.
Welcome.